come up with this model. Okay, so where we have this generator, okay, just for generating all the loads, right? Then we have this world, which actually receiving, okay, receiving the loads through this public events arrive. Okay, then do some statistics inside the count, right? Then we put both of these modules under the parent, okay, under the parent, so that we have one generator, one world. Okay, then we connect them together, we construct them. Okay, then we add them together through these output events to these input events. Okay, and after this is finished, so what we can do is that we just construct a toy, okay, this model for the parents, okay, instead of the generator and the world, but the parents, which actually cover both of this. Okay, then we run them, so you can see what is going on. Okay, here. Okay, so this is what we did last time. So just to recall, what does this really mean? By refer back to this one, okay, the sandbox concept is that basically what we are doing here is we actually have a two sandbox. Okay, it's something like this. Okay, so I just do a simple, quick change of this graph. So basically what we are going to do is we're creating the two sandbox. One is called the generator, the other one is called the world. Okay, so what we do is we actually created some interface for this two sandbox. One point out, okay, so this sandbox is not like fully encapsulated, but rather we come out with this small interface, okay, to allow the certain interactions between this sandbox to the outside. But this interaction can only through the defined interface. Either it's an input events or the output events, can only be these two, okay, can only be these two. Okay, so that what we did is that we create a bigger sandbox, which is called a parent. Okay, so what we do is we actually put this sandbox into this parent. Okay, wow, it's a little bit unclear, but yeah, just imagine. I mean, this is actually a whole like a bigger sandbox. Then within this whole parents, we connect these two together. Then we can actually let this two to interact with each other within this big sandbox. You see that although this is outside of the safe environment of the first one, and this is actually outside of safe environment of the second one, but because of this larger sandbox called a parent, okay, so we can still run the simulation and keep everything within the safe environment. It's actually this a bigger sandbox. So this is actually a simple illustration of the concept of the modular simulation modeling. And sometimes we also refer this as a hierarchical, okay, modeling, meaning that you can actually treat this as sandbox, the big sandbox, as another small one. So for this a big sandbox, you can also identify the input, output, so that later you can put this one under another bigger parent. So in that case, when we build a very complex model, so actually you can do this level by level, layer by layer. Then eventually we can build a whole model by compose all those very detailed logic, okay, using this modular concept. So this actually is some things I want to share with you, I mean, just to conclude what we had last time. So what we are going to do today, okay, what we are going to do today is use this using this modular concept to build a simulation model for this queuing system. Okay, I think this queuing system, if I attended my I think last Friday, actually we talked about this one, right? But we are building this queuing system in a single sandbox, right? Meaning it's a non-modular approach, or in some sense, we actually call this one as an atomic approach. Why is it atomic? It's that everything's within one module. Okay, I mean, by definition, we cannot separate them. Okay, if we do not really know the domain knowledge behind, we are not supposed to separate them. But everything is actually very interactive. It's actually interacted within this sandbox. So we cannot just cut them into pieces. Okay. Yeah, so this actually previously we come up with this atomic approach. Then the way that we design the atomic approach is by using the event-based formalism, the so-called event-based formalism. So if you still recall what I taught in the last Friday, is that we identify, okay, this the state variable. Although I mean this will be the same. Later I will go through with you, okay. But the state variable is some things are same, but the step after that will be very different. Okay, the state the state after that will be very different. So by identify the state variable, so one is a Q, another is M. So I think it's better to use another this one. Okay, yeah. So you see that one is actually this a Q, another is this M. So after we identify this one, then from this system point of view, because the whole system is treated as one atom. Okay, so in that case, okay, we from this point of view, then we look at what are those events. What are those events? Will affect the changing of the state variable. So that's why we identify these three things. Then after that, we also identify what are the like static parameters. So one by one, we actually come up with this simulation model. Okay, by having two two state variable, three events, and the two static parameter. Okay, so this is what we did the last time in the atomic approach. But now in the modular approach, okay, one step we should add in is that immediately after we identify the state variable here, which is actually the Q and M, then we need to decide how do we cut this model. Okay, so I just want to repeat this one again. It will be very important is you see that this DES are the three steps we have, but in a modular approach is that immediately after we identify the state variable, okay, we need to add another step here called the cut. Okay, maybe you can also treat this as a modularization. Before you are looking into the events or statics, okay, so these are all follow after this cut procedure. So what is actually this cutting is doing is actually it will separate the state variables into a different sandbox. Yeah, maybe we can think in this way. So for example, now we have one Q, we have one M. So these are the two state variable. So what we are going to have is here we need to consider, I'm sorry, where is my slides? This one. So we need to consider that, okay, now we need to have a two sandbox, or we need to have a three sandbox, or maybe we just have one, so it will be the same as the previous approach, okay? So one will contain Q, another will contain M, but probably I think here in this QA model, it actually will be another hidden state variable, is how many has been arrived, okay? So if you think about this one as one more statistics, you are actually observing, I mean, the number of the people, the number of the customer which have arrived or have been generated, okay, in some sense. Then you can see that now we actually have a three state variable. Then we actually allow this, the sandbox, each sandbox to contain only one state variable inside. Or maybe I use another way to make this a concept clear is in a modular approach, one state variable can only appear in one sandbox, in one module. You cannot have the queue, the number of queue in both places, okay, in both places. You cannot have the queue both appear here or at another places, okay? It shouldn't allow, okay, it shouldn't allow. So this modularization is actually based on the state variable. This actually, maybe I'll take another example like in the real case. So now we are actually working on the warehouse simulation model and the port simulation model. For example, the port, we have a multiple like yacht cranes, okay, in the terminal. So we looking at the status of the yacht crane. So they have a position information, they have the speed, they have the coordinate. For example, they also have the load. For example, so we want to like so these are actually a lot of the state variables we need to capture for the whole port, because you see yacht crane 1, the state variable can be very different from the yacht crane number 2. Yeah, so the way we actually doing the modularization or cut the state variable is according to which yacht crane it belongs to. For example, the coordinates and the speed, these are the two different set of information. But as long as it belongs to the same yard crane, we put them into the same sandbox. Okay, so by this principle, we cut the simulation models into the modules, and each module will represent a 1 yard crane. Okay, so this is what we are doing. Also, the same thing for the warehouse. Okay, if you consider a situation that we have a different like AGVs moving inside, or maybe you have a different storage equipment. I think the last time the model we did for Macron. So it's the same thing. So if this one is a VLM, so this one is a multi-shuttle. So that's why it's each VLM, we actually treat it as one module. But for the multi-shuttle, although it has a lot of AGV inside, but we do not really separate them because they have a strong correlation, a strong interactions within this environment, so that all the status of the AGVs within the multi-shuttle will be considered, will be grouped together. Then we form a one sandbox. Okay, so this is why, I mean, how we do this modularization is actually based on the state variable. And finally, I think before we move into the code, the last thing you should remember is the modularization is from the methodology actually is from the state-based modeling formalism. Okay, so there's actually three main modeling formalism. So one is called the event-based. So this is what we did for the atomic models using O2DES. Okay, but now when we move to the modular approach, so what we are using is actually the state-based. State-based meaning that we separate the state variable first, then we form the module. Okay, and from the OOP's perspective, you can think of this one as encapsulation. You can think that we actually encapsulate those state variable into object. Okay, so this object and the module, object in the OOP actually is the same as a module. Okay, when we do this O2DES modeling. Okay, so now we move to yeah, I think we still need to go through a certain step before we move into the source code. Okay, so by looking into this Q model, so now we have this Q and M. So now we separate into the different module, and also this generator. So now we have one module, the second module, the third module. Then each module only have one state variable inside. So now the next question is actually this one. It's the same, okay? It's the same, but actually this question will be only under the wall, under the sandbox, okay? You define for this module. Okay, for example, I think this is example what we also did the last session is for the generator. If you consider that, what are the events? What are the events which affect the number of generated? Okay, so we only got one event which actually the generate. So here you see that we are even changing the name of this event. We do not call this arrive because in the sense of this generator, we do not really care the generated loads whether it's arrive or not. We don't care. Maybe there's another layer to filter out something to make them not arriving. Okay, so we don't care. We just look into the generator's point of view. So what are the events affect the number of the generated changes is actually the event of the generate. Okay, so this is we only talk about the event within the modular perspective, the wall of this module. Okay, then the next one we look into the Q. I think these are some questions we chat last time. Okay, at the end of the last session. So what are the events will affect the changing of variable this Q? One will be arrive. Now because of the Q, probably we don't call the arrive, we call in Q. Okay, so this in Q will affect the number to be changed. Then DQ will also be the second event, okay, which will cause a change of this Q. Okay, so this is only from a Q's perspective. We actually create this wall. Then within this wall, we look at the event. Then we call it in Q and the DQ. We don't call it arrive. We don't call it a start, but rather in Q and the DQ. Then we from the server's perspective. Okay, then we from the server's perspective. Then we see that what is actually the number. What is actually the what is actually the events will trigger the change of this server. So we actually have this start. Okay, then we also have the event of the end. Okay, so actually these are the two events. Okay, so actually these are the two events. Okay, So I think this is some things will be clear. Okay, so now let's move to the code. So let's reflect what we discussed just now. We put them into the code first, then we move a little bit forward. Then we see that what are the next steps we're going to do. Okay, so actually the event is not finished. Okay, the event is not finished. So just now is some straightforward event we can identify. Okay, so now, yes, let's still like reuse what we implemented in the last session. For example, the generator, we have this generate events, okay? But I think to reflect what we discussed just now, we can actually have one of the state variable called a number of generated, okay? So we put this one as 0 at the beginning, okay? So every time when this when it's generated, so what we are going to do is just increase the number generated plus 1. Okay. Okay. Then you see that this is a generator. We still use this logic. We still use this logic every 5 minutes. Okay. Every 5 minutes, we actually generate we schedule the next generation. So this generator can actually moving forward, non-stopping. Okay. Fine. Now let's ignore about this output event first. I will show you later. So I will show you later why we need to adding this output events. By now is that this generator is just moving on itself. Okay. Then the second things we are going to create is actually called a queue. Okay. Let's create another one for queue. So for simplicity, so I just do a copy and paste. Okay. So I'll come up with this queue. So this one we call the number in queue. Okay. It shouldn't have any initial events, okay, because this queue is not something we'll send self-initiated, okay. But this queue actually have two events, one called in queue. The other one is called the queue. One is called a DQ. So what we do in the enqueue is we let a number enqueue plus plus. Okay, then we write clock time enqueued. Okay, then here we remove. Similarly, in the DQ, what we are going to do is we'll make this minus minus. Okay, then we call this DQ. Okay. Then similarly, we do for another things, okay, which actually the server, okay. So here we have this thing, the number. Similarly, we have this number in server, okay. So what we have is start service. Start. Then we have this started. For the queue, let's make it enqueued and dequeued. Okay. So server we have started, and this one we have the ended. Okay. We do not have the output events now. We do not put output events now. And this word we can delete, not use anymore. So we have a generator, we have the queue, and server. Okay, so I think this one is a simple and a straightforward, right? So after modularization, we just identify the events, okay, which affect the changing of the state variables within that module only. Okay, now the question is, we need to think about this question, is how those modules interact with the outside, okay? How the sandbox will interact with the things outside of the sandbox, okay? So first, let's look at the generator, okay? Let's look at it's a generator. Whenever there's something generated, right? So actually this is a place This is where the signal is generated. Then you trigger something happen outside. But probably now you don't need to really care about what is really happening outside, okay? Because you're actually looking into the outside from the inside, okay, from this module. So you do not really care. You just need to see that, understand that now there's something you want to send to the outside. Then you will let the rest of the model outside to handle the rest, okay? So in that case, this explains why here, whenever there's a generate, we want to send some information outside. Then here we have this ungenerate defined as an output event. So this is actually a standard in syntax. Okay, we need to follow. And this event is actually a parameterless. Okay, there's a no parameter. So that's why this action is empty here. Okay, otherwise you need to put in something here. Okay, for the things of parameter you want to define. But now because it's a no parameter send out, you don't need to define anything here, and you don't need to define anything here, okay, in this bracket. So this will be the standard form. Then in order to invoke it, is that every time when this general event happens, you need to use this ungenerate invoked, okay, to send a signal to this outlet, okay, and you don't need to consider what is happening, what is connected to this one. Okay, so this will be the key idea. So for this one, actually, we have done with the events of this generator. We have done with the event of the generator. Okay, so you see that to look into the events of the module is not only to identify what are the events which will change the state variable, the value of the state variable, but rather it's also include that how the event will interact with the outside. Okay, so now we actually done this for this generator. Now we look at the enqueue. So just now we said that there is actually two events. One is called enqueue and the dequeue, right? So how does this enqueue and the dequeue interact with the other? Okay, interact with others. So may I just check that whether you think that this enqueue and the dequeue is something's input, some of the input or some output, whether this is the input or the output, okay? Or maybe I ask in another way, whether you think that enqueue and the dequeue is something depends on, will be, I mean, affected by the external factors, or is something will affect the external factors? Someone can answer me this question?
I think they are external.
No, what I'm asking is actually whether it's input or output. Yeah, I know it's interact with the external, but whether it's the internal will initiate the external change, or maybe the external will initiate the internal change. Which way is it?
The external will initiate the internal change.
Yes, yes. So for both? For both?
For both. Yes.
Right?
Yes, yes.
Okay, okay. Yes, yes. Actually, it's right. Okay, it's right in some sense. Okay, later we'll say what are the missing part. Okay, so it's right in some sense is that NQ and the DQ from intuitive point of view is actually something affected, depends on the external factors. So NQ is because someone arrived. Okay, so it's in queue, but with the condition that the capacity of the queue is infinite. Okay, so actually this is one condition. I said there's a certain missing part. The missing part is actually provided that the queue is infinite. So whenever something happens outside, meaning that it's arrived, someone arrived, then it will have this in queue event, so that's your queue length plus one. So just consider the counter example when the queue capacity is finite. Okay, so even when there's arrive, the queue length might not be increased by one. So this in queue will not happen. Basically, it's because the queue is full in some sense. Okay. So yes, I mean, in the current case, when the queue length is infinite, yes. So in queue is input events, meaning the external will affect the internal. Okay. Then DQ will also be the thing. Okay. DQ happens when the next, okay, the downstream server or procedure is able to process, okay, what is waiting for, Okay, so in that case, this signal is actually from the outside to say that, okay, now it can be dequeued. Yeah, because the next step is available. Yeah, so dequeue will also be another input event. Okay, so let's do in this way. Let's do in this way. So in the queue, because these are the input events, so what we are doing here is simply put a public in front of this event so that we change it from the internal event to an external, not external, input events. Okay, so this is actually for the input events. For output events is like a generator. Okay, so this is actually for the output events. This invoke and this ungenerate is for the output events. Okay, so now this is a queue. This is actually the simple step we need to do lah. Okay, for this enqueue and the dequeue. Whether this is finished, okay, whether this is finished, then how about the output events? Whether there's any output events for the queue. Probably, I think we can leave this a question later, lah. Okay, because if there's only queue, when we only talk about a queue, then we do not care, right? When we do not care whether it's output any information, the information the output information can be discussed only when we move to the other part of this system. Then see that only when certain part requires this information, then we can later we can trace back to see that which part is actually is able to provide this signal at what time. So maybe this output event we can leave it a little bit later. So let's move into the server first. Okay. So for this server, may I ask a question that this is start and end event. Okay, so whether it's actually input, output, or it's a internal events. Okay, I think this is some things we asked last time. Okay, whether start and end, do you think is an input events? Is there something affected by the outside, or is an output events which affect something happen outside? Or is an internal event, meaning that it's just something will trigger from internal mechanism. This is a start and end. Maybe I talk about the end first. I think end is relatively easier. So how end will be triggered? What do you think? So maybe Xinju, can you tell me?
When
Yes.
when it's not busy, when the server is stopped, then it will call the queue. Is anything, yeah,
No, I
anything.
mean the end event. I just answer the questions directly. Whether you think the end event is an input event or is an output event or is it something's internal. Okay, so the definition is that input is something's affected by the outside. Then output is something will affect the outside external. The internal event is something triggered by internal mechanism. So for the end event, which kind do you think it is?
I think is can trigger the outside and inside also, because it
It
triggers
can
queue.
trigger the outside, right?
Yes, yes.
And can trigger outside. Okay. Then how about then the next one? What is your next question? So it can be the end can be an output events, right? This is
Yes,
something you are saying.
yeah.
Right? Yeah. The end can be an output event. Yes, it can. No problem. Yeah, then how about the next one? It also can be an input event.
Yes, I think it can just call the queue and call the next one when it's end. Because when the server is stopped, then you will call is anything else want to serve, then you will start again. If got something, then we will start. If nothing, then it will stop.
But now is that we're only talking about within the server. When you talk about the server module, we don't know whether there is a queue. You see, this is a problem.
Okay, okay.
Yeah, we don't need to consider queue at all. Okay. So what I'm talking about is for this end event, how this is a trigger. Yes, you say that any event probably can trigger something outside. I agree. But this thing is actually possible. I'm not saying definitely because of some model is just ended here, so end will not affect anything. Okay. But now the second question is whether this end is a trigger from the outside or you think that end is something trigger from the inside.
Uh,
Yeah, Monica, yes, please.
Yes, sir. Start will be external event and end will be internal event.
Okay, the end will be the internal event. Whether
Internal
start is
event.
an external event, later we can
External.
discuss. Yeah.
Okay,
So
okay,
later
okay.
I'll let you to explain. But yes, end is actually internal event. Why? It's because end is triggered by which event?
Internal.
By
Internal
start.
mechanism. Yeah.
Yeah. End is something triggered by start, and the start is some event of the server. Okay. Okay.
Yes.
So this is
Yes,
how
yes.
when you well, just now we actually identify start and end to be the event of the server. Then we can see that end is actually something triggered by the start. Okay, in the current way. Yeah, because the processing time is something's uh yeah we use to generate the end. So actually you can look into this one. You can look into this one. Start will trigger the end. Okay. So now it's actually these two things we actually put it together. Okay. So the end is actually the internal event. How about the start? How about the start?
Sir, sir, external event
External event. Why?
for for server because we will get it from outside.
You will get this event from
From
the
outside.
outside, right?
From queue. Yes.
Okay. And um, okay, but here is actually some things I think will be a little bit tricky, lah. And also this is a problem. Actually, I have been thinking through for a long time. At the time, I started to build this modular O2DES. Okay, is what happened if the start is actually an external event? What happened if it's a trigger, meaning something arrives, but the server does not have capacity?
Uh, then sir, it will wait in a queue.
It will wait in the queue, but queue is not something the server is considered.
So, sir, this only I was asking you, like when I raised my hand, sir,
Mm,
like if suppose we have one queue which is outside,
mm,
can we have another queue for the server also? Uh, because if suppose something if something is started but server is not able to take it, then a separate,
yes.
yeah, separate queue for server and one separate queue for taking the arrival which is coming.
Right, right. Okay, so I think this is actually a very, very good suggestion. Also, I have been thinking of the same things last time. So yes, I think this is a good suggestion, and also this is being used, okay, in my implementation many times. So in the server, yes, we have this logical queue. You are right. So this queue is something physical. Okay, this is something physical. Okay, it can be a physical space which people are waiting there. But this server internally, we have this logical queue. But this logical queue to differentiate from the queue here. Sometimes we call this a pending list. Okay, it's actually when there is actually a request from the outside, but I cannot serve, then I put into this pending list. I put it into this pending list. So you can see that this server, okay, because of this capacity, okay, because of this capacity, then we can see that for this server, this M itself is not sufficient. It's not sufficient. We need we need another uh, state variable, okay, which actually to assist. It's kind of a auxiliary state variable, which actually to help the server to handle the case when the capacity is not sufficient. Okay, so instead of the M, we have another number here. We have another number here, which we call is actually the number of the pending. Okay, so how many are here, but it's not able to be started. Okay, so I think Monica, I mean, this thinking is very good. And because of this one more state variables here, so we are thinking that this start and end is not sufficient. Because you see that when one load comes in, they actually have a two kind of possibility. One is that it's actually one part of the M. Another thing is actually one part of this pending list. Yeah, because of this, then the two events is not able to handle handle the change of the state variable. So instead, we will create another additional event here. Okay, so instead of start and end, we'll have another one. We have another one. So in some sense, sometimes we actually uh, call this one as a request to start, and another one is actually start. Okay, so you see that for this server module, because of the capacity, then the M itself is not sufficient. So that's why we need to have additional state variable to track the pending. Then we need to have additional events. Okay, so we have a request to start and the start and the end. So you just think about the one load. If it's just a request to start but not start, meaning what? Meaning it's waiting, it's pending. Okay, but when these loads have been through request to start as well as the start, meaning that it's actually being processed, right? So if an event has been through request to start and end, meaning that it have finished the processing, right? So can you understand this part? So now instead of two events, the server is actually we need to have three events. And Monica, does this solve your questions?
Sir, sir, we will make one more queue like that.
Yeah, actually it's not a one more queue, it's actually a pending list. It's actually a logical queue. Okay,
Okay,
it's actually a logical queue inside the server, so which we call the number pending. Okay,
okay, sir.
yeah,
Okay,
okay. So um, you
How
use
Habib,
yes, yes,
I have
yes,
a question.
yes,
So if you go back to the slide, okay, that one is the M is for one server
yes.
or one capacity, right?
It can be one capacity, can also be finite capacity, can be multiple, but as long as it's a finite, then this pending list or this tracking of the pending loads is necessary.
Yeah, but the queue is supposed to be in the queue, right? So meaning that the server should not receive any request or any starting event if the server is not ready. So inside the server, they it should be a capacity that telling that, for example, if it's already the capacity is five and it's five of them is in process, for example, then the queue should stop and should not send any message to the event to the server.
Yes, yes. Okay. Yeah. So actually, what Riza presented is an alternative approach. Okay, it's actually an alternative approach, and also this approach I thought about this first. Okay. So yeah, in the earlier version of the, I don't know whether we still have the earlier version of the ODS modular model. So actually, the queuing system is implemented in this way, is that the queue will check the availability of the server first before sending something in, and once it's sending something, then the server has to take it because the server is have already make sure that the capacity is enough. Otherwise, the server will throw an exception, okay, to say that okay, you never check with the availability before you're sending this load. So this actually is some things we implemented last time in the earliest version, and this system we actually call this as a push system, a push system. Why this is the pushing system is actually the queue is actually the one responsible to send out, to check the information and send out the load. Okay, so this is actually a pushing system. By now, the things we just discussed is actually a pooling system. The pooling system meaning that it will be the lowest, the downstream, okay, will be the downstream's responsibility to decide what is the time to make the physical flow. Okay, so this will become a full the pooling system. And in this pooling system, the upstream is only responsible to tell the request to request. Okay, then it's a downstream will remember this request and pull the load when time is available.
But
So
the
this will,
logic is supposed
yeah,
to be like that, right? So the server is supposed to be not receiving, but actually pulling the queue, right? It's supposed to be like that, the logic.
The
because this one
server,
is the server is observer, right? So they are observing they are observing the queue. If there's a queue there and the server is ready, it's
mm,
open
mm.
lah, or we can, the server is open for process, then it should pull the signal from the queue.
Yeah, the server should pull. The server should pull the load. Okay, the server
Ah,
should pull
should
the
pull
load.
the correct, yeah.
Yeah.
The
So so
the signal, yes.
yeah, should pull.
Mm.
No, the signal is sent from the queue to server, but the server is pulling the physical flow. Server is actually pulling the physical flow.
So are you saying that the queue will always sending a message to the server?
Yes. The queue will
Oh,
sending the message to a server, and
mm,
server will pulling
okay.
this a physical load. And okay, so based on my experience, there's a no right and a wrong for this two approach. Okay, there's a no right and wrong for this two approach, especially in the MMCQ. We can use a both method, okay, to implement this. Okay, so both of these two method is right. But the problem is that when there is one queue but multiple server, when there's one queue and a multiple server, then the problem comes is the pushing system will be less flexible than a pulling system.
Yeah, that one I agree. The server should
Yes.
pull, not
Yeah.
yeah, not queue pushing to the server.
Yes.
That's why,
Because when the
because the
queue
queue is
push,
supposed to be queue. Yeah, it's supposed to be queuing and wait for the
yes.
server. So it's like someone in McDonald's, they're calling next. So the
Yes,
server who's the
correct,
one who
correct,
say
correct,
next,
correct,
then the
correct.
queue will go out and then request not request go to the server side. Okay.
Yes.
Yeah. Okay. Okay.
Yes. Otherwise, I mean the communication, if in a pushing system, the communication will be much more complex. Yeah, because I mean each server need to update its availability to the queue,
Mm.
and they need to like make a decision which server to push to. I mean if it's a multiple servers after, okay, so this will be a very complex.
Yes.
So
So
that's
the
why, yeah,
multiple server also can have multiple capacity, right? Like say I have three
multiple
server.
server, each server have a different capacity.
Correct.
Yeah,
Okay. Okay.
yes. Okay.
So that one later we can discuss because I have some idea using I observable for the coding instead
Ah,
of using I enumerable. So
okay,
in the
okay,
queue is we using I enumerable. In server it's supposed to be using I observable
okay, okay,
because server is observer. So instead of waiting sorry, instead of queue pushing data to the server, event to the server, then server can do like just observing is there any queue
okay,
available. Yeah.
okay.
Later we can discuss it.
Yeah.
Okay.
Yeah. And also, I think we can, for all the like exploration we are doing, we can use the same example, lah, the MMCQ
Yeah.
here,
Okay.
so that
MMCQ.
we
Yeah.
can do a
Yes.
comparison. Okay. So yeah, so here we just want to mention that here we are using a pooling systems. Okay, so Q is responsible to sending the message to request to start. Okay, then the real moving will be triggered by the server. Okay, when this queue is really started. So that's why you see that we have this three events. So this is actually for the information passing in. Then this is actually for the physical flow to start. Then this is actually the end. So if you actually in this structure, so just now we agree with one thing, right? So this end event is something triggered by the start, right? So in that case, this end event should be scheduled in this start events. Okay, it should be scheduled by this start events. So let's say I just use this the similar things as here. Okay, so we can just ignore about the time span now. So later I will explain. Okay, but now let's do this. We just let the end to be something scheduled by the start after a certain time interval. So we are clear that the end is actually internal trigger. Whether it's actually output events, we can leave it later because said output whether it's output events really depends on whether it's required in the bigger system. Okay, so at least now it's actually internal. It shouldn't be the input event because it's not the trigger by the external, but actually triggered by some internal event. So now I want to check with maybe Monica again, because just now you answered my question, is from this point of view, whether you think the start is an internal event or is an input event.
Sir, start will be then internal event because it is getting from some intern request to start. So it
Yes,
is
correct. Correct. Exactly, this is answer lah. I expected lah. It's in this case actually we make the logic clear. Is actually we separate the previous ambiguous the two things. Okay, actually it's a mix of one request to start, the other one is a start. So now after we separate, is a clear. Is this a request to start? Will be something to receive information from outside. Okay, so after that, it will based on condition. So in certain case, will can start, but in some cases it's not able to start lah. Okay, then this start is actually something only when condition is satisfied, then the request to start will trigger. Okay, so in that case, this will be the public event and this will be the internal events. So now with these things, okay, let's trying to make everything. So we just need to like link the logic, okay, within this module server. So I think the server is one of is the most complicated in this example lah. Okay, so you see that when request to start, what we need to do. Okay, if you still remember the last time when in the atomic model, so when there is actually arrive, it's a similar thing now. When there's arrive, so what we are going to do, we need to check whether the server got capacity or not, right? So it's the same thing. When now we request to start, we also need to check whether the capacity is enough. So we have this a number in server, but it seems we have a one thing missing is actually the static property lah. So this is actually one things I want to the last step. Okay, you see that here. It's actually the last step. Is after events is clear, then we need to see that what are those static properties. So in this case, one of the important static properties is actually the capacity. Okay, public. Okay, so this capacity will be yeah. So yeah, because this is the static properties, so we need to check. Also, let's make a comments here. So this will be the dynamics property. Okay. So in the server, we need to start with introducing the capacity. Okay. Then it will set this one as a static properties of this server module. Okay, so when request to start, what we are going to do is we will check, okay, whether our number in server is smaller than the capacity. So only when it's smaller, then I will trigger the start event. Okay, we trigger start event. So here is that better. I mean, we can both start using the schedule start, or maybe we just use the start. Okay, and also I think the last time I mentioned to you by default, we should use a schedule start. But now, actually later, we found out one of the problem, although it's very rare, okay, but it may happen is that sometimes when there's a multiple event scheduled at the same time, for example, request to start and the end happens scheduled at the same time, then if we do in that way, schedule may trigger some problem. So that's why we need to make sure the time the request is a trigger when time is condition is satisfied, then it will be executed. Something will be executed immediately. Okay, so that's why we do in this way lah. So when it's capacity is sufficient, then immediately we execute this part. Okay. Otherwise, so what we are going to do is we'll increase the number in pending. Okay. So this actually on the requested to start. Okay, so you see that this is start becoming internal event because it's triggered by here. Then in the start, then you will do this thing, then you will trigger the end schedule after some times. Then in the end, after we reduce this number in server, okay, so what we are going to do is, I think this is something that Shinju just mentioned, because I think just now we do not have this separation, so I think it's a little bit confusing. By now, Shinju, can we ask a question? So for the end, what we are going to do in the end event? Should we trigger start or should we trigger request to start?
I think it's request to start because we need to confirm the capacity is bigger than number in server.
Why? Why
Yeah,
we
because
need to confirm this one?
yeah, because we need to make sure the capacity got someone inside. Is it?
You see that when this number in server is reduced, okay,
Yeah.
which meaning that we're already sure there will be one capacity, right? Otherwise, there will
But
be something wrong.
but sometimes the capacity will be 0, then it will not possible to start, right?
Capacity can be 0.
No, I think the waiting people, the waiting in
Yeah,
the
so
list.
which are we going to check? Whether we are going to check this one or we are going to check this one.
Yeah, yeah, sorry, the number in pending, yes.
Yeah, then because of that, which event we should look for? The end event. So what is really care is what? Or maybe we say this thing, when there's someone finish the processing, if you like a trigger request to start, who is actually requesting?
I think is the number.
All the pools you are looking into is actually someone already requested, right?
Yes.
So what this end event should look at is actually someone requested to start but not started yet. Am I right?
Okay.
At
Yes.
the end
Yes.
event, you are looking into someone who actually requested to start but not started yet. So what it's going to do in the end event is actually looking into the number pending. Okay, actually this one you recorded how many have been requested but not started,
Yeah.
right?
Yeah. Then after that, we just start when the number pending is not 0.
Yeah,
Then
then just start.
yes.
Right? Okay, so what we are going to do in the ending is that we need to check if this a number of a pending is larger than 0. So if it's larger than 0, what we do, we'll reduce this one by 1, then we will start. Okay, understood this part?
Okay. Okay.
Yes, yes. So you see that the two way to trigger to start this to trigger this start. One thing is from externally, from external. Okay, from the external. So from the external, it's because we know that the demand is not 0 because it's required to start. So the demand is there. At least will be 1 to enter, right? To start, right? So in that case, we check the capacity. Okay, so when the demand is clear, we check the capacity. If the capacity is there, we start. Then here in the end, we know the capacity is there because this one minus minus is something n. So there actually there's a one capacity released out. Then we need to check whether the demand is there. So if the demand there, then we start. I think this is a logic. Is a logic. So when they need to start, two conditions need to be there. Once the capacity is there, and then the demand is there, then we can start, right? So request to start and end is actually two different ways to trigger this start event. Okay, and also if you look into this code, sometimes actually we do in this way lah. We do in this way. You see this a number pending. Okay, number pending is a plus got here, then got minus here. So sometimes I think a better way is to do this. When we have this request to start, no matter whether the capacity is enough or not, okay, we increase the pending first. Okay, we increase the pending first. And when it's started, okay, then we will minus this number in pendings when it's got started. Okay, when it got started. Okay, so you see that in the case when this is satisfied, then you are actually adding one, but immediately at the same time, okay, because this executed, then you are -1. Okay. Otherwise, I mean that this a person, okay, this a demand still go through the logical queue lah, in some sense. They still go through the logical queue, plus and the minus here. Then in that case, when in the end, when we check the pending is there, then we don't need to minus here lah. We just go to the start. So in this case, actually the code will become more clearer lah, from my point of view. Okay. So when you request, you increase the pending. When you really start, you decrease the pending and increase the service. Okay, the in server. Then end you just decrease the in server. Okay. Yeah. So
Sir, last time which problem Hondong raised, in which the pending list was there and in queue was there, but sir, they are not matching always all the time. The pending list number is different in many situation uh, in comparison to number in queue. Sir, last time you give the explanation which uh, Hondang raised, sir.
yeah, I actually later I go through the code. I think the reason is because of this. I
Of this,
think
yeah,
the reason
correct.
is because of
Yes,
this one. But now
yes,
if you
yes,
change to
yes.
this one, it should be exactly the same.
Okay,
Okay, it
okay.
should be
Yeah,
exactly the same. So meaning everyone actually go through this a plus and a minus.
correct, correct.
Okay,
Yes.
everyone actually go through this a plus and minus. Yeah, so later I actually understood what you mean. So yeah, so I mean, this is actually the ways you can remember. So actually, if you look into the many of our other implementation, so most of them is actually follow the same kind of paradigm, meaning that this one is just a plus, right? But if you really want to like track the individual loads, so we will actually have a list here. So we add a list, remove from this list. So actually the similar at this process. When you have the hour counter, so you actually take observation here when the plus and take a observation -1, okay, here. So it's actually a similar pattern. Then everything you can actually see this request out to something and you have this star and end. Sometimes this request to start also called a attempt to start us. Yeah, so it's actually a very similar pattern. I think this is actually some things you can try to observe from the other part of the code. Okay, so I think because of time limit, let's just quickly go through this model, try to connect them together. Then I'll show you what is happening now. Okay, so just now as we mentioned that this will be the output, the input events request will start, right? Then we also have one thing is you see that for this queue, okay, you see that for this queue in the middle, okay, in the middle. So just now we said that arrive is the queue will be affected by the in queue event and the dequeue event, right? But actually, we haven't talked about how this queue will affect the external, okay, uh, the external party, okay? So basically what we need to see is that when there is actually arrive in the queue, then this server need to be notified, okay, to know that how many are actually um, pending or start waiting to enter, so that later this server can pull them like one by one. Seems like this one will have a name list, okay, have this name list, so later can call them one by one. So whenever there is actually one in queue, then the server need to be notified. Okay, so in that case, we can see that we can simply do in this way is that we create another event called a ready. Okay, these are some things we can do. Or maybe, yeah, I just thought about some idea because it's yeah, okay, let's take back my words just now. Actually, no need to create another queue. And let's try another thing. Okay, you see that when this as I said, that whenever there's any like arrival, they need to notify the queue so that they can be in queue. Also need to notify the server, right? So what we are going to do is that for this generator, we connect the generate to the in queue. We also connect to the request to start to the server. Okay, then once the server started, okay, then we actually pull this load from this queue. Okay, so in that case, okay, what we need to do here is for the server, we need to have output events. Okay, we need to have output events. Probably I think in the training, I need to draw this one into a certain like a diagram, so it will be easy to see. So what we are going to do is that we actually found that this start event can also be a output events. Yeah, it's because whenever it's a start, then we need to move one load from the queue. So that's why this start is some things we need to notify to the outside. Okay. Then for this parent, so what we are going to do here is we have a queue here. Also, we have a server here. Okay. Then we need to connect them all together. We need to like create them under the parent, connect them together. So the way we connect them, okay, so you see that for this server, we need a capacity. So let's see the capacity. We set it to maybe 2 now, temporarily. Yeah. Later we should also expose this one as a parameter for the parent. Okay, you see that when generator is on generate, so we let it to connect to the queue in queue. Okay, and also we let the same thing to connect to the server or the request to start. And also we need to connect the server to the queue by doing this way. The server dot unstarted every time when server is really started. Then we need to notify the queue to the queue. Okay, so I think now we are able to actually finish this model. Then we can see whether it can be wrong. Okay, so I think the model run properly lah. The run properly is just some more things we need to set. It's actually one last step here is for the static parameter lah. So for the static parameter is to similar as the last time, but now is that we need to identify those static parameter from the perspective of this module. For example, here for this generator, number of generator is actually the dynamics, okay. But what is actually a property, the static property of this generator is actually this one, the inter-arrival time, the mean inter-arrival time, okay. So that's why we can put this statics as similar as the last time. We call this overly arrival rate. Okay. Then we do the same thing here, hourly arrival rate. So what we are going to do here is instead of the 5 minutes, we use 60 divided by this hourly arrival rate. Okay, so we can see that the static properties related to generator is actually only this one. And the Q, actually we have a nothing. Okay, so this one is actually dynamics. Okay, for the Q, there's a no static parameter because there's a no capacities for this Q, so we can just ignore about that. Okay, then we go to the server. Okay, for the server, the capacity is actually one thing. Another is actually the service time. Okay, this is service time or the hourly service rate. Let's put this as the hourly service rate. Okay, so in the constructors, we also got this hourly service rate. Okay, so here instead of 5 minutes, we have a 60 divided by the hourly service rate. Okay, so this is actually the one thing is the static parameter for each of the module. So what we need to do at the parent for the root is that we need to passing this whole set of the static parameters from the parent and to each of the child. Okay, so in that case, we need to have the number of the server, which actually capacity. Then we need to have the double for the hourly arrival rate and as well as the hourly service rate. Okay, so here we see that for the generator, we need to taking this hourly arrival rate. Okay, then for the queue, nothing, and for the server, we need to taking the capacity, not the given number, but not the constant, but actually the parameter we're passing, and also the hourly service rate. So basically, this is just a passing of the parameter. Sorry, this one BOB arrival rate. Okay, so this is one thing. The second thing is about the random generator. Okay, so you see that this now the generator will have a random stream inside. Okay, then we actually control by this seed. Okay, then it's actually used here. For the server, we also have this random stream. Okay, so it's meaning that here we also need to passing the seed. Actually, no problem. Then the problem is that at the parent, okay, we need to give a seed for both of this. So it's wrong for the server to be like this. Okay, actually the generator is right. Is we need to generate a seed to initiate the child module. Okay, but in this way. So for the server, we should also do this default rs dot next. So we generate a seed from the random stream at the parent. Okay, then generate seed for each of the child. Okay, so this is what we can do. So after this, for the parent, what we are going to do is give a capacity, then we set an hourly arrival rate, then we set a hourly service rate. Okay, then we can run this model. Okay, so currently I have not putting any of the statistics. So later you can actually follow this idea, then put the hour counter into the queue and also put the hour counter for the server. Then you can actually get the information. The result should be the same as the atomic model lah. So probably you can I mean yourself you can take a try. Okay, so I think that's all I want to show to you for this modular approach. Yeah, sorry, I think later I also need to clear out what have been true in this pre-training session, then try to do a better preparation next time in the bigger training. Okay, by probably I will show some better PPT slides to demonstrate idea. Okay, so anyway, thank you very much for your feedback. Any more questions before we end this session? Okay, so I hope no. Then okay, I'll see you tomorrow.